Okay, now we are ready to start to do some scraping. We're going to use this page here, examplewebscraping.com, which looks like this. This is the first page, and you could click Next and go to the next list of countries. So what we want to do first is just collect the links on this page. And then we're going to dig deeper into each of the pages, because if you click on these, you do go to a page that has information about each particular country. And the organization of those pages are all the same. So, for example, they have the population of Afghanistan, they have the population of Albania, and so on, and they're listed basically in the same location in each page. The first thing is we can right-click on this page here. I'm not showing you the page, I'm just showing a screenshot of it, so I can't really do it right here. But you can right-click on the page and choose a page views source code or something like that, and you'll see the source code for the page. And if you sort of scroll through, you'll see one part where you can see Afghan. So, for example, it starts here, table, and it's got a link for the page that we're linking to. That is, when we go to here and we click on this, that's going to take us to a different page, and that link, that address is here. Now you can see this is not a full address. It doesn't start out as HTTP. In other words, it doesn't start out like this. In fact, what we're going to have to do is prepend or put this in front, take this and put it in front of this address, because this is what's called a relative address. So it doesn't tell the full address. But we are going to want we're going to need the full address for each of these pages, for this page, for this page, for this page, and so on. Anyway, when we view the source code, we see things like this, and we want to practice by getting the names of the countries, or maybe getting the URLs for these pages. So we could do various things. So here's some of the code we're going to use. So we're familiar with this. We're going to import beautiful soup and BS4, time, and requests. Now, what we're going to do is we're going to take the web address of the page, this page here, the whole page, which is this address, and we're going to put it, we have a module called requests, and a request has a get method. So we're going to access that method. We're going to do request.get. So basically we can think of this request here as kind of an instance. Remember, we said we take instances dot a method. So we can think of this as kind of an instance, slightly different, but we can think of it as an instance. So it's the instance dot get, and then we put in the web address that we want to get. And this request package will then go out and get this website's HTML and deposit it basically in this variable page. Now, so we just expanded it, and we can see that it's a long string. It ends there and starts here, and it contains all the HTML. And also you can see that it has these new lines that we talked about before, so that even though it's a long string, we could get it to print out as a bunch of lines. In fact, I'm curious to try that. So remember that if we print, then the print will interpret those /n's as new lines, which is what's happened here. Now we get all these new lines. We don't see the /n anymore, because print doesn't display them, but it has interpreted the /n's as new lines. Okay, so page text has the new line characters in it, but when we print it, when we pass it through the print statement, instead of showing us the new line characters, it actually interprets them as new lines and gives us new lines. So it looks like this. Okay, next we're going to do this. And Beautiful Soup basically will take page.text and it will make it even prettier than what print did. So print basically made it kind of pretty, right? This is much easier to read than the original long string was, this long string. So it kind of cleaned it up. But Beautiful Soup will do more than that. So when we run this Beautiful Soup here, when we pass page text into Beautiful Soup, remember page was a requests type of object, and we could do page.text. Now we're going to put page.text into Beautiful Soup, and this is going to be a Beautiful Soup type of object. So we're going to be constructing, so Beautiful Soup is the class, and we're going to be constructing an instance or an object of the Beautiful Soup type. So soup is going to be an object of the Beautiful Soup class, and therefore it's going to have all the methods that Beautiful Soup has, or that Beautiful Soup offers us. And one of the methods is what's called find all. I've seen it written, actually I think I've seen it with a find underscore all also, but anyway, so we can apply find all to soup because soup is a Beautiful Soup type object, and Beautiful Soup has, you can do a little research and find all the methods from the Beautiful Soup class, but one of them is the find all method. So we can use that using the dot notation on soup. Now Beautiful Soup apparently handles other things besides HTML. Maybe there are things like XML and other formatting. And so we have to tell Beautiful Soup that we're giving it HTML. So we say that by putting this in there, by saying HTML parser. You have to write this in this for this argument here, and we're putting in page text here, and we get out an instance of type Beautiful Soup, which we're calling soup. So let's do that. Okay, so I just did that, and I have soup. And I don't know what would happen if I type soup. So it has a lot of text in there. I think it's going to look pretty much like this, but what Beautiful Soup will do is if there's any sort of poorly written HTML, it will kind of clean it up. Like suppose that in HTML page, they had forgotten to close the body with this closing body tag. Then Beautiful Soup would put that in there. So it sort of cleans up the HTML if the HTML has to be cleaned up. So I'm not going to print out this. Okay, so now we can do things like find all the links in the page, or we could find all of other aspects of the page. For example, here's the HTML again, and we might want to find all of the images. So let's try that first, just to see what it looks like. So I believe this will find all the images. So let's try that. So here, there aren't too many images, and here they are. You can see the image code here. And you can see the URL for the sort where the image is located. Again, this is not a complete URL. It's what we call a relative URL. It doesn't have the full HTTP and so on at the beginning. Okay, but we're not really interested in finding the images, but we are interested in finding all the links. So let's try that, and we'll call it links. And now let's look at that. Now, when you do the find all, we just did find all before with images. And if you look carefully, you'll see that it gave us a list. You can see that this is a list. It's a list, and if you look for the commas, so there's a comma, and there's another comma. So it's a comma divided list, that's what a list is. And so you can see the first element is this, and the second element is this, and so on. So it's going to work the same way for the A tags, it's going to return a list of all the URLs. But again, it's not going to give us the full URLs because in the original web page, they weren't written as full URLs. They were written as relative URLs. So it's going to give us that. Okay, so here they are. And if we look at them, we can see, for example, here, there's one that's for Afghanistan. So let's look at that. That goes from here to here to here. So you can see, it starts with the A tag, href. And here, this again is not the full URL. And then there's actually an image associated with it. And then it goes to here. So going back to the web page, that's the URL associated with this. Okay, so anyway, links is a list. So we could do something like this. Okay, so that's the very first element in this list, goes to here, which is what we have there. And then if you wanted to, so you could take this element, first element, and you could get its text property. So let's try that. So you can see that it just took this part. So this is the text property of this link. So we could do the same thing with this one. And we would get the second one, which is here. What does this give me? Or let me say, let's leave it at this one. So this is the fifth element in the list. And then I'm not calling the text property. I'm calling this property. So let's see, what does that give me? So that gives you the actual URL. So the A sort of has much more than just the address. It has the address right here, but it also includes like information about an image, name, and so on. The text here, the text property, the name of the country, and so on. So it has much more. The A tag has much more than that. But if we want specifically the URL, that's just this part. This is how we can get that. If I want the next one, I would do that. Okay, so we are going to want the complete URL, not just the partial URLs or the relative URLs. We want the whole URL because we're going to want to scrape the underlying pages, and so we're going to have to access the underlying pages. By underlying pages, I mean we're actually going to try and scrape what's in here, and we're going to try and scrape what's in here. And so we need to get these addresses. We don't just need the beginning, or rather, I don't know, we'll call this the end or the beginning, but we don't just need this part. We have to have the whole thing to scrape it. But for each page, this page, the page for Afghanistan, the beginning is all the same. So we can just prepend whatever is the relative link that we are given. We can just prepend this to it to get the full URL. So we want to create the full URL. We'll call it URL. So how do we do it? So we already saw that links 5 href gives us the relative URL. So we can just do a concatenation of two strings. This is a string, and this is another string, and we just concatenate them with plus, and that will give us the full URL. So let's try that. Let's print the URL to see if it looks right, and then test it by pasting it into the browser to see if it actually finds the page. So in this code here, this occurs down here. I'll just copy this and put it into here. So I'm defining URL, and this is for, well, I don't want the ith one, but let's say I want the 5th one. So this is the relative URL, and then I'm concatenating that, string concatenation, with this string, and hopefully that forms a full URL. So let's see what we get. So we get that. Now let's see if that's actually a real URL. Will actually take us to the right page, to a proper page. So let's try it. Okay, let's review how to get the links that we want to scrape. So we see that there are the links that we want to scrape, but there are also some other links up here, here, and so on that we don't want to scrape. So how do we get the ones that we want to scrape? Let's review that. So we're going to get all of the links here by using this code. So let's try that. Okay, I edited it. I put print links in there, and we get them. So this is a list. Let's copy this list, and let's open this up in Notepad++. And since it's a list, it's going to be comma separated, and we are going to replace the commas with the new line. So let's do that. So let's go to replace here, and comma with new line. You have to make sure that this is checked, and I think that's it. And replace all. Go back to the beginning. Okay, so we can see that there's a link here, but that's not the one. That's a login link. We don't want that. And then there's a link here and here, and finally we get to, this is the first one that we actually want to scrape. So that is in position 6, and when we count in Python, that would be index 5. So we see that we want to start with index 5 in our code. Here's what we want to do. We want to prepend this to this. So we're going to have links starting out with I equals 5. We're going to get the URL from that. And then we're going to print it out just to see what we got. Then we don't forget to do this. We have to increment I by 1. Otherwise, we're going to get an infinite loop, which I actually did by mistake. Anyway, don't forget this. And then we'll go back up here and check if it's less than this, whatever this is. If it is, we'll continue, and we'll have another URL. We'll print it out, and so on. So we can just make sure that we're getting all the URLs by going through this loop. So let's try that. So I'm going to, instead of typing this all out and so on, it's too hard to use the interactive right now. So I am going to just take this part up to here, copy it into a new file, and just test that out. There's some extra stuff in here, but it's not going to affect anything. So I'll save it. Okay, and let's try running this and see what happens. Okay, now was that all of them or not? Yes, that was all of them, like this, the last one. And we didn't pick up this one, which we don't want to pick up. Now you will want to later on figure out, we're not going to do this in this tutorial, but you will want to figure out how to go to the next page and then collect those as well, but we're not going to do that. Okay, so with this code, we were able to collect all of the URLs. Now, what do we want to do each time we get a URL? We don't really want to print them out. We don't need to print them out. So we want to do something with them, with each URL. So, well, we could do all kinds of things. So let's decide on something to do. So let's decide, or actually before we decide, let's just go through this presentation. So for homework, or for an exercise, you could try to do the same thing with a for loop instead of the while loop. Okay, anyway, the results we just saw look like this. And so the first thing is, can we build a list of populations for the countries? And the second thing is, can we build a list of pairs of country names and their populations? This kind of structure is called a dictionary. So when you have what are called key value pairs, you have the key would be the country name, and the value would be its population. So when you construct that kind of arrangement, it's called a dictionary. But anyway, let's try for question 1 first. Can we build a list of the populations for the countries? So once again, if we take a look at this page and we click on this, we see that there is an entry for the population next to the word population. And, of course, the same thing for all of these. Next to the word population, there's an entry for the population. So if we left click on the part of the page you want to inspect, so right here shows we want to inspect this, so we could left click on it like that, but this is not the actual page, so this won't work. From the pop-up menu, you choose Inspect. We're going to see something like this in the pop-up menu, and you're going to see this number here, which is the population. And you're going to see that this is surrounded by a TD tag, and it has some class name, W2P_FW. So we're going to have to use this kind of information to get this number. And all the pages use this same class number, W2P_FW. Okay, so we're going to have to use that somehow. So let's just try that. So click here and then right click and do Inspect. And you can see this, like we said, there's the population, there's this strange code. And the same thing if we go to a different page and double click on that and Inspect, still get the same strange code there, and it's still in a TD. So how are we going to get this number? Because that's what we want to do. We want to get this number for each of these pages, because we said question number one was we want to build a list of the populations for each country. We could have chosen anything to do, but we're just going to try and do that. We could have gotten the geographical area of the country or whatever other information they provided. We could have built a list of those, but we're going to just try to get a list of the populations. We printed out the URL for each of the pages with each of the links. And then what we're going to do, we're still in this while loop. So with this URL, with a particular URL, we're going to do we're going to go back and visit our old friend, request.get. This time we're going to put the link to one of the country pages in here. Last time we put just the original page in there. But now we're going to put a link to, or this was the front page, and this is one of the actual country pages now, because we've constructed a URL with the actual country page. We're going to put that into here. We're going to call it country page, and then we're going to pass it, just like before, we're going to pass that into Beautiful Soup. And then we can use find all again on this soup object, soup.findAll, TD, and the way that you get that particular class item is with this, W2P_FW. We're going to see all of this. We're not done yet because we don't want all of this. We just want this number here, 29,000 to here. So where is that in this list? It's actually going to be a list. We'll see that. You can see that here. You have this, and it ends somewhere. It ends somewhere down here, but it is a list. You can tell that it's a list because we can see what it starts with. So it's a list. We want the third element. So let's see, how can we get that? So going back to our full code here, we have find all here, up to here. So let's see. So let's add in whatever we didn't have before. So let's add in this to our test3 file. Okay, so now what are we doing? We constructed the URL. We're going to get it. We're going to pass that through to Beautiful Soup. We're going to do this find all. And let's print out some of these and see what kinds of things we're getting. So let's do, they said that when we do find all, we're actually going to get a list of things. So that's this. So let's print out just the third element in the list. Let's print out the second element in the list. And let's print out the text of the second element in the list. Let's do this whole thing. We have to run it. We have to save it first. We run it. Okay. Well, what happened? So we did it multiple times, which I didn't mean to do. But let's look at, we printed out the URL, then we printed out the third element, the second element, and the text. Let's see that. We printed out the URL, we printed out the third element, the second element, and the text of the second element. So now you can see that, and we did that for each of the pages. I didn't mean to do that for each of the pages, but I had it in a while loop, so it actually kept repeating itself until it ended up here. So we can see what we're looking for. So we don't want this. This was the third element in the list. This was the second element in the list, and that seems like what we wanted. Except we don't want all of this, we just want this number. And so we saw that if we took the second element of the list, dot text, we got this. So let's kind of look at them together. So here we printed the third element of the list, that was this one. Then we printed the second element of the list, that was this one. And then we printed the text of the second element, and that was this. So we want the text of the second element, and that's for each page, because this is for the next page. Remember that this was for Afghanistan, then since we did a loop, we also got this country, and we also got this country, and we also got this country. But each time, the third element, the second, I shouldn't call this the third, actually, this is the fourth, isn't it? Because of the way Python counts. So this is actually the fourth element in the list. But anyway, in the list of this list here. So we got the thing with index 3 was some kind of abbreviation like AF for Afghanistan, but it was this whole thing. And then the second element was this, which looks like what we want, but we don't want all these tags around it. But if we do the text of this thing, we get this. So we're moving in the right direction for collecting the populations for each country. So what we want to do is we want to take something like this, which will give us the populations, and we just want to collect it into a list. So we're going to do it for the first link, because remember we're doing this in a while loop. So we're going to do it for the first link, then we're going to get it for the second link, then we're going to get it for the third link, and so on. We'll get the populations for each time. We're just going to collect those. So let's see how we do that. I defined up here an empty list before the while loop. So I put it up here so it's not being affected by the while loop. And then I just did, it's called population list. And then I just did, once we've collected these links from find all on soup, then I'm just taking this, and we have an append method for lists, and I'm just appending what? f2.text, and that's going to happen for each page that we're scraping. So then we're collecting all the populations in this population list. Okay, I'm also doing something else here, but I don't want to get into that yet. And then let's just print out the population list that we've collected. So let's add in, we're adding in this stuff into our test 3. We haven't explained this yet. We'll just take out that, and I don't think we need this. We'll take that out, and let's see what we get. So we're going to collect all of them into population list, and that's going to be done in the while loop. And then we're going to be finished with the while loop, and it's going to be all stored in population list. And then we're going to print it out here. Print the list of the populations is, and then print out the list. Let's see if this works. Now, I didn't really want to go through all of this, printing it all out, but we did it. But anyway, at the end, the list of the populations is, and we have it. We have all of the populations now. So going back to question 1 here at the bottom, can we build a list of the populations for countries? We just did that. And then the next thing we could try is, can we build a list of pairs of country names and their population? So we'd like a list, like Afghanistan, comma, or something, 29 million. And the next country, this one, and its population, and this country and its population, this one and its population. So we'd like to get that kind of structure next. So what did we do? Let's just review. We found out where this population was located on the Afghanistan page. We saw that it was in here, but actually when we do this find all with this special code, we get many TDs. We get many TDs, and then we had to find the right one. We found out that it was the one with index 2. So here's what we got, and I saw that it wasn't this one, and it wasn't this one. This is the square kilometers, and the next one is here. For some reason it prints on this prints on a new line, and then It was this one. So it was the third one, which means index 2. So we got that, and we did it for each page. And we saw that here. We print the population list, and that's this here. Okay, the next thing is we want to try and build this dictionary. So can we do that? Okay, so if we want to do question 2, which is to build this so-called dictionary. A dictionary is not a list, so a list has square brackets, and a dictionary has these kind of brackets. So this is how you construct an empty dictionary, and a dictionary is going to have what are called a key and a value, key-value pair. So the key might be Afghanistan, and the value might be its population, and then the next key might be Albania, and its value will be its population. This is how we start out with an empty dictionary, and we don't have an append. We don't use append for a dictionary, but we use update. So here it is here. It's encircled in blue, and you can see this was called country and population, and I'm using the update method on it. And you have to, it's a method, so it has that and this, the round brackets, but inside there you have to use the curly bracket and the curly bracket, and then you use this semicolon to separate the key from the value. Okay, so what was the key? The key was Afghanistan, and where was that? That was the fourth in the TD list, index of 4. That was the key, so we put that on the left of the full colon, and we put the value. Where was that? That was in the element in this index 2. So we put that to the right of the colon, and that's going to, and this is again inside the while loop, so it's going to do this for each URL. So it's going to construct these key value pairs, collecting the name and the population for each of the links that we're scraping. And then we're going to print this out. Then we're going to print out the dictionary down there. Down at the bottom, the second to last line says, the dictionary of country and population is, and then we're going to print it out. So let's see what that looks like if we run it. And here's what you get. The dictionary of country and population is Afghanistan and its population, this one, and its population, this one, and its population. Antarctica has 0 people, and then this one. Okay, so that worked. Now we have this dictionary. So you can see it's name, colon, the value. The name, colon, the value. That's called a dictionary. Okay, so let's quickly take a look at some code which will give us a graph. So we're going to make a graph, and we're going to be using this package called plotly.express. So you need to install it with pip. So let's take a look at that. After you've done that installation, first of all, we can remember we have the country and pop, and they have keys and values. And you can, let's see if we can just do this. Let's try to put that in here. Okay, so you can see that it gives you, when you do the keys, you just get the names of the countries. And if you do the values, you get the populations. So you can extract those from the dictionary. But they are not, this is not really a list. It kind of looks like a list, but it's called dictionary keys. So it's not quite a list. So if you do something like this, you take that keys, for example, and we say coerce it into a list. Then, and let's say we assign it to objects. Then if we check objects, it's actually just a list. Okay, now there's a concept in data science they call something a data frame. And basically it's just a spreadsheet. But of course Python doesn't exactly have a spreadsheet, but it's like a spreadsheet in Python. So to make our dictionary into a data frame, we can do the following. Okay, so first of all, note that we're not going to be covering data frames in our course, but I'm just giving you this information. So if you want to make it into a data frame, we're going to need also, I forgot to mention, we're going to need pandas to do what we're going to do. So you need to import pandas. You don't have to install it using pip, I don't think. I think it's available without installing it using pip. So we're going to use pandas. We're going to use the shorthand PD for pandas. So we're going to do, we can do this pd.dataframe. So this is something that's in the pandas module. And you have to take countries where you take whatever you want to be in one of the columns of your spreadsheet. You can give it a name. I just gave it a name called countries, which I happen to spell improperly. But I'm taking the keys for that column, which I think is what is correct. I think we said that the keys were the countries. Then you can have another column. You can call it population, and you can take the values in this case for that one. And in this way, you make this kind of spreadsheet. Remember, a spreadsheet has columns, and we're defining the columns here. And you have to say dictionary here, D-I-C-T here, and so on. So you have to use this format and use this data frame, pd.dataframe. And now I have that as what we call a data frame. It kind of looks like a spreadsheet. So let's just try that. Let's try that and see if it works. And then let's print it out to see if it really looks something like a spreadsheet. You can see it sort of looks like a spreadsheet. So that's called a data frame in data science. Now to use this plotly.express, you need to take that and you need to do some kind of, this is I guess another pandas method called melt, and you have to do this. So you have to take the data frame that you have, .melt, and ID variable is countries. I guess that's probably the variable along the x-axis of the graph that we want to print. So once you've done that, then you have to do this to get the graph. So you have to do px bar, and then use this tidydf, which is I guess part of this plotly.express package. You have to say that, and then you say x equals country, y equals value, color equals countries, or you can do this one. This will give you a different graph, or you can do this one, and this will give you a different graph. So let's just try all of this out, and we'll see that we'll get actually 3 different graphs, and you can sort of figure out what these different arguments or parameters mean. What's the difference in terms of the graphs that they produce. But let's just run this and see the graphs. I'm going to go run. I don't know. Okay, so it shows up in your browser, and these graphs are actually interactive. That's what that plotly.express gives you. So you can actually put your mouse over and get some information, and so on. Plotly.express has many kinds of graphs, and there's many different kinds of interactiveness that you can get out of these graphs. But anyway, that's what this one looks like. That. Then another version that we just created looks like this, and then the third one looks like this. So this is how we could visualize the work that we did, and we can see that we also got that data frame as well.